This meeting is being recorded.
Great, thanks, Brooke, and thanks everyone for being here this evening. I just wanted to say a quick hello and thank you for being here. I think you all are familiar with Watsonville Wetlands Watch. I won't do my whole spiel, but I did want to highlight a couple of things that are happening that are great opportunities on topic to Pam's topic, which is, I think, really critical to the mission of Watsonville Wetlands Watch. We have this amazing wetland system, but there are significant plastic issues both in our wetlands in the Monterey Bay, and our restoration work is really a critical part of addressing that, though there's a lot of other issues. But we do have we have been collaborating with the County of Santa Cruz and the City of Watsonville and a number of other partners on a new collaborative effort called Trash Talkers. And we've been organizing a monthly trash cleanup in one of the waterways. We've done the Pajaro River, we've done Casterly Creek and Green Valley Creek. It hasn't been every month, but almost every month we've got folks out to pick up garbage, plastic, and an amazing amount. You'll be shocked and surprised at how much is off our roadways throughout the county. And the effort of the Trash Talkers is to make Santa Cruz County the cleanest county in California. But it's a great effort, and I hope you'll join us for a future stewardship and cleanup day. And we also have a tree planting event this Saturday at Pajaro Middle School, and it's going to be at from 10 o'clock to 12 o'clock. We'll be planting trees throughout the school as part of our urban forestry work that's helping to revitalize the city's tree canopy cover from 9% to 30%, and with an emphasis on school sites, because that's a really important part of improving academic experience and the overall environment, both in Watsonville and specifically on schools. So hope you'll join us this Saturday if you're around and want to help us plant some trees. And I just want to say thanks for being here, and excited to hear Pam's talk. Stephanie?
Hi, everyone. I'm Stephanie Rios. I'm the Education Programs Coordinator here at Watsonville Wetlands Watch, and I've been working here for since 2016. And I first got connected with Pam through our program, Green Careers Program, which was a high school summer internship program. And the first time I met Pam, she had us out in Corralitos Creek sampling the water for microplastics. And I learned about microplastics in college, but until you see it in the water that you care so deeply about, it was a game changer for me. And we did microplastics with summer interns in 2018 and 2019. And then Pam had us with high school interns in 2020 working on an ag farm and dealing with microplastics in fields that are left over from strawberry growers. And that was also a huge moment for both me and the interns. So I'm just so glad that Pam is here and is continuing all this great work. Just a couple more things about Pam. So Pam's the Water Quality Programs Manager for urban and rural watersheds with the Monterey Bay National Marine Sanctuary. And she helps growers conserve irrigation water used on crops and reduce the amount of agricultural pollutants that enter local streams and rivers that eventually empty into the ocean. And Pam earned her Bachelor of Science in Chemical Engineering from Stanford University and received her Master's of Science in Coastal and Watershed Science and Policy from Cal State University, Monterey Bay, where she worked on several projects related to agricultural sustainability, food safety, greenhouse gas production on lettuce fields, and the use of satellite technology in forecasting evapotranspiration. My goodness. So I'm looking forward to this talk. And once again, thank you, Pam, for being here. And I will pass it on to you.
Thank you. Thank you, Stephanie, for that great introduction. I am Pam Krone. I do work for the Monterey Bay National Marine Sanctuary. I've worked there about 10 years now, and I've been lucky because my projects are constantly changing, and that keeps life interesting for me. I always like doing new things and trying to think about things in different ways. So more recently, I've been working on the plastic issue, starting in agriculture, and now I'm moving over to beaches a little more and looking at the plastic issue on beaches. So I'll share some of the research that I've done, as well as some of the concerns that the sanctuary has about plastic. So thank you, Watsonville Wetlands Watch, for all your great work. I love the trash talkers and the tree planting and all the other restoration work you do with wetlands. And the way that you involve students in your work. I think it's so terrific, and I've loved going out with the students every year. It's really a fun thing for me to be able to interact with them and see them get excited and interested in things, and see them in their process of discovery about, looking at microplastics through the microscope, or, or picking up field plastic out of a field and just being amazed at how much there was. I think I weighed that plastic afterwards, and I think it was like 90 pounds of plastic that we took out of the field. It was just a huge amount. So it's been fun working with you all, and thank you so much, Stephanie, for involving me in that. So I'm going to go ahead and share my screen. And as Brooke mentioned, I'm happy to be interrupted along the way. I know that it can be kind of long and boring to listen to a talk for a long time, and I'd rather address things that are of interest to you. So if there's something on one of the slides, if you can just go ahead, I guess, and put it in your chat, and then Stephanie or Brooke can interrupt me and ask the question, and we'll just take a little pause, and then we'll go on once it seems the question's been addressed to the best of my knowledge, or not addressed if I don't know the answer. So can you all see my screen okay right now? Okay, great. So this just shows you the location of the Monterey Bay National Marine Sanctuary. It's, of course, off the coast of California and extends from just north of San Francisco down to Cambria. So, and it goes out about 30 miles. So that's the extent of the sanctuary. And that's the water body that I'm interested in trying to find ways that we can all prevent pollution and protect the habitat for the wonderful marine mammals and fish and animals and sea turtles and everything that lives out there. It's been called the Serengeti of the sea just because there's just so much diversity in the sanctuary. We have lots of different kind of mammals and invertebrates and fish and birds. And as you all know, because you live near here, it's really a treasure. And so we'd like to do what we can. And certainly plastic is one of the big issues that we have. So the talk today is on plastic movement from the land to the sea in the Monterey Bay National Marine Sanctuary. So some of the questions that I'll address is, why do we have a growing plastic problem? Why is it getting worse and so quickly? When we think of plastics really as having been invented in the 1950s, they've only been around for 70 years, and they've grown into just a huge problem. So they're both a problem and a benefit. So we'll talk a little bit about that. Why does plastic get into the sanctuary? Where does it come from? How does it get there? How does it affect marine life in the sanctuary? And then what is being done or could be done to reduce plastic movement into the ocean? So I'll give some very cursory answers to these questions. There's just so much that we don't know and so much left to be discovered. So I'll do my best to give a little bit of an overview, but there's just a huge amount still to be learned. But here are some facts about ocean plastic that really it impacts most species in the ocean. People who have studied it and researched it and looked at, under microscopes and in the stomachs of species, or looked at species that get caught in plastic, from the tiniest plankton to the blue whales, the very largest mammals on Earth. Plastic impacts all of those species. So because plastic can be so small, it can be eaten by plankton, and they've found ways to take imagery of the plankton and see that those little particles of plastic inside. And so then of course it bioaccumulates up the food web into the species, up above, from the filter feeders who feed on the plankton, and so on and so forth, all the way up to the blue whales. Plastic has been found in more than 60% of all seabirds and in all types of turtles, and about half of the turtles that have been examined have ingested plastic. It's in their gut or their stomach of some kind. We don't know how much travels from their gut into their bloodstream or other parts, of their bodies, but we do know that it's there in their gut system. Every year, 8 million metric tons of plastic enter our ocean. And that's on top of what's already in the ocean, which is 150 million metric tons that are circulating around in the marine environment. And as you all know, the problem is that it either doesn't break down, or it just breaks down very, very slowly. So it does break down sometimes, but mostly it breaks into smaller pieces, and it takes a long time for it to totally decompose into a substance that is no longer plastic. Globally, the estimate is that over 100 million marine animals, that includes the birds and the mammals and the fish, are killed each year by plastic waste. So, it's not benign. It does have a harmful effect. For instance, in birds, when they ingest plastic, they have these little finger-like projections in their intestines, and the plastic disrupts iron absorption because it blocks the pathway in their intestines to the iron, and that stresses their liver. So, it has an effect on the systems of the birds and other creatures that ingest it. Flesh-footed shearwaters eat more plastic as a proportion of their body mass than any other marine mammals. I just thought that was interesting. And then other ways that plastics cause harm is that they are charged, and other chemicals adhere to them because of that charge, including pesticides, water repellents, flame retardants, softeners, and phthalates. So all of those things adhere to the plastic, so that when something eats that plastic, some plastics are actually toxic in and of themselves, and others are not toxic, although they can be physically damaging by, well, like in the example of the birds, causing other problems. But some of them, then they carry these toxic chemicals. So those are just some ocean facts that I think speak to the problem of plastic in the ocean. And this is not just the sanctuary that I'm talking about here, but this is globally, worldwide, the kind of issues and problems that we see. So it was interesting, a study just came out about whales and their consumption of plastic. And so gray whales and blue whales were studied along the California coast, and humpbacks too. And they found out that per day, the blue whales ingest 10 million pieces of plastic. So they are filter feeders. Their mouths are open as they're swimming through the ocean, and they're catching, the krill as they swim through. And so they're ingesting plastic both from the seawater itself and also from whatever's in the krill that they eat. And so humpbacks, of course, are smaller, and they're fish feeding versus krill feeding. So they do ingest a little bit less plastic, only 200,000 pieces a day. And that's still a lot of plastic. And we don't really know what kind of damage that's causing. That's yet to be discovered, but we do know that's a lot of plastic. And not only are the whales eating plastic, but here are these little teeny larval fish that are smaller than a quarter. And they're eating these little microplastics that are teeny tiny. So all the way from, these 2 millimeter little teeny fish eating these little 500 micrometer pieces of plastic, up to the whales. All of them are ingesting the plastic. And so we all know that not only do things eat plastic, but they get trapped by the plastic. And I'm sure all of you have seen the pictures of, the seals with the 6-pack rings around their necks, and the different birds in the caught up in nets or in fishing line, or just other plastics that have been left on the beach. So they get tangled up in these plastics, and then it can, if it's around their neck, it can cause them to have swallowing problems. Or if it's around their feet, it can cut off their circulation and cause them to lose a foot. I think we've all seen that in some of the local gulls who get caught up in fishing line and lose a foot. Or it can just retard their movement. It can keep them from feeding, because if you're dragging a big line of plastic, you're not going to be able to travel as quickly, and you won't be as good at catching your prey. So it's really a problem to get caught up in plastic as well as to eat plastic. And one of the really sad things is that birds are mistaking plastic for food because it smells very similar. Algae and things grow on top of this plastic. And so then the plastic takes on the smell of what they tend to eat, and they mistake the plastic for food, and they ended up feeding it to their babies. And then their babies aren't getting the food they need to grow and thrive. Instead, they're getting plastic, which sits in their stomach and can't be digested, and isn't providing them with nutrition. So it's really having an effect on bird populations because of that. So here's just some other pictures of some of the plastic problems. Here's a mother feeding a baby a cigarette butt. There's a gull trying to eat a plastic bag. There's a teeny little seahorse carrying around a little piece of plastic. And sea turtles, we know those try to eat the bags. And then there's a whale that's gotten caught up with plastic and is having to drag that plastic and having a hard time doing that. And then, there's that little bottom left-hand corner is a tiny little microscopic creature. And that blue line in the middle is a piece of plastic fabric that's gotten inside of it. And then the picture in the upper right just shows how plastic travels up the food chain from, these little tiny creatures that eat the microplastics, and then the fish eat the tiny creatures, and by doing so eat the microplastics, and then the seals or whales or other creatures eat the fish, and so on, and including people. It gets into our food source as well. So this is kind of a complicated picture, but this just shows some of the different effects of plastic. It reduces the stomach volume because it takes up a lot of space, and a lot of animals, they can't pass the plastic. If it's a big piece of plastic, it just can't pass beyond their stomach, so it gets stuck there and reduces their stomach volume. So they eat less. It reduces their growth rate. It causes damage to their stomach tissues. It causes them to get parasites because they're weaker. I mentioned that pathogens or hazardous chemicals can transfer from the plastic into their, into their body and bloodstream. So it causes mortality, fewer individuals reproducing, thus affecting the population of the creatures that eat it, and even up to altering the communities that live in the ocean. So some kinds of, like birds, like we saw the bird that eats the most plastic, the animals that eat the most plastic get affected the most. And so that causes change in the marine ecology, in the kind of communities that live in the marine ecosystem, because the ones that are more affected, there are less of those individuals. So we actually see changes in the composition. What kind of things live in the marine communities because of the plastic effects? So why is the problem getting worse? So maybe I'll just pause the question for a second, because I'm going on to another topic. Are there any questions so far?
Not yet, Pam.
Okay. All right. So we all know that plastic is an amazing invention, and that its production is continuing to increase, not linearly, but exponentially. And it's expected that it's going to continue to increase exponentially. Less than 10% of the plastic that's produced gets recycled. And because and that plastic's being found in all environments. We have a big trench in the Monterey Bay National Marine Sanctuary, and it's deeper than the Grand Canyon. There's plastic down in that big trench. Plastic has been found on the tops of mountains. Most of the plastic you can see in this diagram, the orange color in that circle, that's the plastic that either gets discarded to landfill or gets illegally dumped and just abandoned on beaches or in fields or, on the streets or wherever. So there's just a small amount, 10% gets recycled. There's some that's still in use, the plastic that's still valuable and still has a use. And so there's some of that kind of plastic out there. Some plastic gets incinerated. Incineration can cause air pollution depending on the quality of the incinerator. It's illegal to burn plastic in the open in Monterey, but some states like Florida still allow plastic burning. So some places, it can be incinerated in ways that contain the dangerous chemicals that come off of the burning plastic. But still, the vast majority, 70% of it, is just thrown out or discarded, sent to landfill, or even worse yet, not sent to landfill and just out in the environment causing problems. So plastic is used in all the sectors of our economy. Packaging uses the most plastic, which is sad because that's pretty much a single-use plastic. Once we buy the material, we don't have any use for that packaging and we just throw it away. So the more opportunity we have to buy things that are not packaged in plastic, the more we'll be helping to tackle the plastic problem, because packaging makes up the majority of plastic use. So if you can buy things that are in cardboard containers or, paper containers or, not in plastic, then that's a big benefit, just because packaging is such a huge plastic user. Plastics used in construction, in the pipes in our houses are made from plastic. There's a lot of other things that are made from plastic in our homes and in our buildings. Transportation uses plastic in our cars and our vehicles. Textiles, the clothes we wear, of course, have plastic. There's, of course, other consumer products that have plastic, our phones, our telephones, our, pretty much everything, our staplers, our boxes, we have tons of plastic. And then there's just a lot of other plastic. So plastic pretty much is in every sector of the economy. It's valued because of its durability, its longevity, and its low cost. Plastic has been a terrific invention, but these same characteristics that make it so desirable are also what makes it an environmental nuisance, hazard, and menace. So it's low cost, which means we don't value it, which means we just throw it away, which make it a nuisance and a hazard. If we lose a plastic spoon on the beach, we don't worry about it. We just leave it. Whereas if we'd taken a nice piece of our silverware to the beach, we probably would have been a lot more careful with it. So it's these same things, the low cost, the durability, how long it lasts. It's all these qualities that make it desirable and is why it gets used so much, but it also make it a menace and a hazard. So we, as humanity, we really have a love-hate relationship with plastic. We love it for the benefits, but we hate it once we have to figure out what to do with it when we're done with it, because it's very hard. It's hard to recycle. It's hard to dispose of properly. I know I still get confused about what can be recycled and what can't be recycled. And I try really hard to recycle, and I know it's hard. And it's hard because it gets mixed with so many other materials to the point where it can't be recycled, because it's on the surface of something, something is metal and has a plastic surface. So it just really can't be recycled once it's mixed with other things. Or in agriculture, I've worked a lot with plastic, and sometimes there's different types of layers of plastic in the same material. And just because it's different types of plastic, it can't be recycled because it can't be brought back to a single type of plastic that could be reused. So, it's hard to recycle. The best thing I think is to try and not use it to the extent we can. But, that's hard to do too.
Pam, we did have a couple of questions.
Sure.
So Lenny asked if you would be addressing at all what happens to the plastics that we put out in the recycle bin here in the Monterey Bay. Is there anything you want to say about that?
Well, there's a great waste management facility that we have. I don't know if you've had a chance to go and visit it, but it's at the dump, really. And there they have a sorting line where they sort out plastic of different kinds. And first they do it. They have a manual sorting where they have people sorting through the plastic and manually throwing out the things that get into the recycling bin that shouldn't have gotten there. And then after it goes through that, they separate it by density. So they have these blowing machines that blow the different densities of plastic into like different bins. And then they have some like infrared eyes that reflect plastic to figure out what type of plastic. So they try to sort it into the different types of plastic so they can sell it to an end market where it can be recycled. Because, plastic has to be separated because there's about 12 different kinds of plastic. It's not one thing, it's many different chemistries. And each of those chemistries has to be separated out and recycled separately. So at the waste management facility, they try to do a really good job of separating out the plastic and putting it into separate bins. And then they have a big compactor that they squish it down as densely as they can, and then they sell it and ship it off to a recycler. So that's what happens to the plastic that goes into your bin. And occasionally they have times when you can go out and see that facility, and it's really fun to visit. So, you know, if you have a chance, go and visit it, and you can see what happens to the stuff you put in the recycling bin, and it's really interesting.
Thank you. Do you want to take a couple more questions now, Pam?
Sure.
Okay.
Yeah.
So we have a question from Stephanie about what happens to us when we inhale microplastics.
Now that is something I don't know about. So plastic is in the atmosphere. We are inhaling plastic, but we don't know if it affects our lungs or, you know, in what ways it might affect it. You know, I don't think anybody's really studied that much. And I obviously don't know everything, but from the different sessions I've listened to and heard, plastic can be harmful to people, but I haven't heard of anything in that particular study, but you know, that studied that particular question, but that's an interesting one.
Thank you. And then we have one more question right now from Tani about with the move to biodegradable to-go containers like forks, etc. Do those break down in a time frame that helps marine life? Or if they wind up in an animal's stomach, is it still going to cause the same harm?
Now that's a terrific question that I myself have asked, and I don't know, but I'm going to look for a study, and if there's not one, I'm going to probably do one because I've been wondering that same thing. I just haven't seen anything about if it, you know, if that plasticware goes from the beach into the marine system, you know, and something mistakes it for plastic, does it break down in the creature's stomach so that it becomes eventually non-harmful? Or does it break down in the marine environment more quickly so that it becomes non-harmful? You know, that's a really great question, and somebody needs to look at that. So plastic goes through a life cycle. I'm sure you all know this. It gets produced from barrels of oil. It gets manufactured, and a bunch of different resins get added to it to make it have the qualities that are wanted. Some kinds of plastic, you want them to fold. Others, you want the plastic to be rigid. Then it goes into an end product, and it's packaged and distributed. And then hopefully it's used and reused. The more we can reuse plastic, the longer its life and the better off we are. And then it eventually finds the end of its life where it goes to landfill, and or some places are starting to burn it and try to at least get some energy from the burning of the plastic. So that's pretty much the life cycle of the plastic. And we're trying to find ways to extend that life cycle, either through more and more reuses of the plastic product, through higher recycling rates of plastic. I've been working in agriculture with drip tape, and drip tape can be recycled, but only 7 times. You know, after the 7th time, it just can't be recycled any longer and has to be disposed to the landfill. So we're trying to find ways to increase the recycling rate, ways to use it for energy, and ways to reuse it so that we don't just use it once. So in terms of ocean-wide plastic in the ocean, we don't really know how much plastic is out there. So scientists develop these different models to try to figure out how much plastic's in the ocean. And this one is from 2015. And so you can see that that's kind of the range between 93,000 tons to 236,000 tons in the ocean in 2015. And you can see that it's not uniformly distributed across the ocean. There's the red spots where there's more plastic, and the blue spots where there's less plastic, and the in between, yellow, and green. So it's not uniform in the ocean, but it's distributed, pretty much everywhere across the ocean, but just in different densities.
Pam, some of us can't see your screen sharing anymore.
Oh, okay, let's go back.
Thank
Let me
you.
cancel it and start over again. Okay, can you see it now?
Yes, thank you.
Okay. So what the problem with plastic is it does not biodegrade into other chemicals. It just breaks into smaller and smaller particles, mostly because of the sun. So the sun causes it to degrade, but of course we can rip it and tear it, and it can be abraded on the ocean floor. There's other ways that it breaks into smaller particles, but it starts out as buoys or fishing nets or cigarette lighters or cups or bags or bottles. And then those eventually get broken into smaller and smaller pieces, microplastics and nanoplastics. And then where do they go from there? So from there, they can be ingested. So that's a seabird, and that was, it was just, on the beach. Somebody took a picture of it, and as that bird was decomposing, you could see that its stomach was filled just with a lot of plastic debris. As they've dissected fish, they find a lot of plastic in the guts of fish. I've read some studies that plastic can get into the tissues of the fish we eat. So it's mostly in the guts, but it can get into other tissues, like the muscles, which is the part that we eat. And then, of course, seals eat more than the muscles. They eat the whole fish. So it does get into the seals and the other things that eat the fish. So there was one study by the Monterey Bay Aquarium Research Institute on marine microplastic, and they were wanting to know, is there a lot of plastic in Monterey Bay? So the interesting thing is that they studied from the very top of the bay, from the surface, which is at the 0 point there in that diagram on the left, the very top, down to 1,000 meters. So going way down, and they found that there's plastic, because it has different densities, tends to be at all levels in the water column, from the surface all the way down to 1,000 meters. But there's more of it in some places, in some levels than others. So between like 200 and 300 meters, where that blue sort of blob is the widest, that's where there's the most plastic. So creatures that live in that zone are more susceptible to plastic than creatures that live in the zones where there's not as much plastic. So, so fish tend to feed in different zones depending on where the creatures they eat are. So that's another reason why plastic doesn't affect everything in the same way, because it is in different densities in different zones of the ocean. But you can see that the density of plastic in the ocean is from 2 particles per meter cubed. So a meter is about a yard. So if you imagine a box that's a yard by a yard by a yard, that's approximately a meter. So there's between 2 and 15 or 16 pieces of plastic per cubic meter of ocean water. And so the predominant type of plastic is PET, polyethylene terephthalate, I think is what that's called. And that's used in single-use plastic bottles or clamshell containers. So that's the kind of plastic that's the most predominant in our sanctuary. Although there's a lot of other kinds of plastic too. besides that. They found about 10 different kinds of plastic. So how much, if we try to take that finding that they have and look at the Monterey Bay National Marine Sanctuary and say, well, how many pieces of plastic are there in the Monterey Bay National Marine Sanctuary? So I took the cubic miles of the sanctuary. So it has about 4,480 cubic miles of water. And so I took those meters and transformed them into cubic miles. So, which is about 18 trillion cubic meters. So, and if we have 5 to 10 pieces of plastic per cubic meter in the sanctuary, that means that in our sanctuary, we have between 90 and 180 trillion pieces of microplastic. And so that diagram that you see is, we were doing a trawling study where we were looking for microplastic on the surface of the Monterey Bay National Marine Sanctuary. So we trawl with this net behind our boat, and it's like a big net that we pull behind our boat, and it collects pieces of plastic in the net. It's called a manta trawl. And then we take that plastic and we filter it through these little filters like the one you see on the right. And then you can see those little pieces of blue and yellow, and that's the microplastic that we pulled out of our manta trawl. And so that's what microplastic looks like in the ocean. And that's directly from our sanctuary. And that's what we saw from this manta trawling event that we did. So these are all the types of plastic that was found in that study in Monterey Bay. So polyethylene terephthalate, polyamide, which is in ropes, and plastic, I don't know, plastic that's used to contain things, polybicarbonate, polyvinyl chloride, which is used in piping, and polypropylene, which is used in those little strawberry strawberry containers, as well as some kinds of tapes. So it's just very common household items that are used in a lot of the plastic. So how does plastic get into the Monterey Bay National Marine Sanctuary? Well, there's a lot of different ways that it gets into the sanctuary. It comes down rivers. It's carried by rivers into the sanctuary. It comes from storm drains. So if people have plastic things on the streets that get washed into our storm drains, then those storm drains can enter either the river or directly into the ocean or onto the beach. So from the storm drains, it comes from the air, so, as Stephanie was asking about the air we breathe and does that harm us? Well, it is getting into the sanctuary too from the air. It's carried by currents and waste treatment facilities. I think you've heard about laundering your clothes, which then that water is wastewater that goes through the sewer system to the waste treatment facility. And then there's plastic particles from that wastewater that gets from the waste treatment facility into the sanctuary. There's beach trash that goes into the sanctuary. And then there's ocean activities. So those first things were all mostly things happening on the land that go into the sanctuary. But then there's activities in the ocean like fishing or crab lines, or sometimes vessels wreck and break up and they have plastic in them. And so that plastic also gets into the ocean. So there's a lot of different processes or different ways that plastic enters our Monterey Bay National Marine Sanctuary. So just in terms of air, it's estimated that there's 270,000 tons of plastic in all the air around the globe. That's not just Monterey Bay, but that's all of our air. Rivers transport both macro and microplastic. I've stood on the river and collected microplastic samples, and as I'm watching the river, I've seen just huge pieces of plastic tumbling down the river and going into the ocean. And then currents. So, waste management is, just to put it frankly, less carefully controlled in some countries than others. But we have these currents that carry plastics that might be, dumped off the shoreline of one country and then carried by a current to another country, so that, if it's not carefully controlled, I know we've all been to third world countries and seen some of their rivers and streams, and ours aren't in great condition. And I'm not trying to say that we can't do better. We can do a lot better. I've picked up plastic trash along our waterways, and there's a lot of it. And I love the trash talk. I know that you guys have collected a lot of trash too, but there's other countries that are worse than we are, where disposal is into the ocean. And so again, so those currents can carry trash, from Asia across the North Pacific and then down the California coast. And today I was in a meeting and somebody was hypothesizing that, well, trash probably gets carried from beach to beach because it's going south along the California coast. So maybe it's in San Francisco, it washes out with the tide, then it goes to Half Moon Bay, comes in on their tide, is on the beach there, and then washes off with the tide and comes down to Monterey and gets washed onto our beach, and so on and so forth. So the plastic can get carried, from beach to beach by the tide and the currents. So in other cases, plastic is lost directly into the ocean. So it's directly piped into the ocean from our waste treatment center. So that right-hand picture shows where in the ocean the waste treatment center outfall is. And so the microfibers from washing clothes, microbeads, which used to be in a lot of facial products, which are now banned, but those used to contain a lot of plastic. I see women with coloring in their hair, and I think it's really pretty, but a lot of that is made from plastic. The glittery hair stuff, it's made of plastic, and that can get washed off when we wash our hair and go into the regional waste treatment plant. And some of it gets removed, but not all of it. So there's the ocean outfalls where that plastic then goes into the ocean. Of course, sometimes fishing line, the nets break apart. Nobody wants them to break. The fishermen don't want their nets to break. They want to keep their nets and reuse them, but they do break. Sometimes we have grounded vessels that fall apart, or in some cases, trash can be thrown overboard from ships or ocean liners or other kinds of ocean traffic. And of course, sometimes container ships lose containers in the ocean and the whole container falls off. So that happens too. Plastic can also get into the sanctuary from the beaches. So I mentioned tides before. So tides come up and down the beaches. Wind blows along the beaches and can blow plastic into the ocean. Waves come up onto the beaches and can take plastic from the beach into the ocean. Plastic on the right-hand side, that's a storm drain, and you can see that there were some plastic things that came out of that storm drain, and that was carried to the beach, and then that can in turn be taken out to the ocean. So plastic can go from the beach to the ocean in those ways. People think that the biggest transport of plastic to the ocean is by rivers. That's from some of the papers I've read. That's what people think is the major transport. But it gets to it from all these ways: from the atmosphere, the air, from rivers, from ocean currents, from boats and gear and just trash thrown overboard, from sewage treatment and beach trash and storm drains. So I did a study of transport by rivers into the ocean because I was working a lot in agriculture at the time. And so we went out with nets and we collected microplastics in agricultural streams that were dominated by agriculture, so that upstream of those locations was primarily agriculture and not urban areas. And we took what we caught in our net and we took it to the lab and we separated it and we looked through the microscope at the microplastic particles, and we differentiated it into film, fiber, fragments, pellets, and foam. And then we analyzed, we went into, I think it was 7 different streams that we took the netting, did the net samples in, and then analyzed all the kinds of plastic we found. And we found that the most kind of plastic that we saw was pellets. And basically that was fertilizer pellets, where they put this plastic coating around the pellet so that it will have a slower fertilizer release, so that instead of just dissolving into the water all at once, the pellet will dissolve more slowly because of that plastic coating. But unfortunately, that plastic makes these pellets more buoyant. So there was a rain event right before we collected a lot of this plastic. And unfortunately, the farmers who had happened to put plastic on their field at that time lost a lot of plastic that just floated away with their rainwater and into the stream that we were sampling. But there's also fibers that get into it, and foam and film. So I know you've all seen that the film that we put on to protect our strawberries from, I guess, from weeds and from things, the bugs that eat the strawberries. So it also gets in from the films here. So just as a comparison, we found in the different streams, the 7 different streams we looked at, our particles were dense, were in those streams at a density between 1 to 61 particles per cubic meter. So kind of similar, the same order of magnitude that earlier study I showed you about plastic in the Monterey Bay, which found 3 to 15 particles per meter squared. So some of our streams actually had more particles per meter squared than the sanctuary. So a lot of plastic coming down the streams and entering the sanctuary. And that's just the microplastic, not those big macroplastic pieces that I also saw floating down the streams. And that's another study that I'd like to do, is how much macroplastic is coming down our streams and into the sanctuary. These were just the different streams that I looked at, and that shows you the variability in terms of, you know, how much plastic and what type of plastic we found in those streams. Natividad Stream, Quail Creek, Santa Rita, the reclamation ditch. Let's see, I've even forgotten Tular Creek, the Merritt Ditch. So those are some of the places that we did the sampling, just in case you're familiar with those names. So then, you know, in terms of agriculture and its contribution to plastic, worldwide, it's estimated that agriculture, and I'm talking about not packaging, but field plastic, agriculture uses about 5% of the plastic that's used worldwide. So overall, it's a fairly small plastic user, but in our area, it could be larger, just because we're a very productive area and we have a large amount of agriculture. And I haven't been able to find anything about what percent of plastic use in our areas for agricultural operations, but I did do a study by crop type of how much plastic is used in agriculture. and by different kinds of crops that we have. So you can see here that that because of how much is planted, how many acres are planted, and then how much plastic each kind of crop uses, which really varies between crop types, that we use about 20 million pounds a year of plastic in agricultural fields in Monterey. This was done just for Monterey. And that strawberries are the biggest user of plastic because they use it for their drip tape, and they also use it for mulch and for their fumigation tarp. So it's the biggest user of plastic. But there's a lot of other big plastic user, including leafy greens and grapes and cane berries and coal crops like broccoli and cauliflower. So, at Monterey County, that's a huge amount of plastic that's being used each year in our field. So as a result of these findings, the Monterey Bay National Marine Sanctuary decided that we would really try to make a difference here. So we've started reaching out to the waste management and trying to encourage them to start recycling more of the field plastic, because they get a huge amount of field plastic coming to the waste management, and then it's just filling up our landfill, which becomes a big problem because our landfill's only projected to last about 25 more years before it's totally full. And then we'll have to figure out where else are we going to put our trash. So the slower it fills up, the longer it's going to last. So they really wanted to work on the problem too. So we have a current, we've been able to find people willing to recycle a lot of the agricultural plastic, the drip tape and the hoop house plastic, not the mulch yet, but at least the drip tape and hoop house plastic. And we're working to find somebody to recycle the mulch. And we're hooking them up with our local waste management, and they're helping us package it in a way that's efficient to transport it to the recycling facility. And they're offering a discount to growers so that currently growers don't have to pay if they deliver clean plastic that's separated, separates out the hoop house plastic and drip tape so that it can be recycled. They don't have to pay the $90 a ton drop-off fee. So they can get free drop-off by delivering this plastic in a clean condition. So it's benefiting everybody. It's benefiting waste management because it's going to fill their facility slower. It's benefiting the growers because they can drop it off for free, and it's benefiting the recyclers because now they have more plastic. That's a high cleaner plastic source for them to recycle. So we're really proud that we've been able to bring together those groups of people and create a program that's going to reduce the field plastic that's disposed in Monterey County. And our next step is to try to take it to other counties. We want to expand to Santa Cruz County and San Mateo County and other counties throughout California. But it's a very time consuming to bring together all the partners and create this alliance and this partnership. It takes a lot of time. So we're kind of trying to tackle it one county at a time and trying to use some of our partners like the San Mateo Resource Conservation District to spearhead some of the efforts in other counties. There's a CSUMB class that did a study on how much is coming from city storm drains into the sanctuary. So you can see, it's pretty similar between 2 and 35 pieces of plastic per cubic meter coming out of storm drains. So pretty similar to, and it just a little bit lower actually than what we were finding on the ag fields. So those are the study of what was coming down from the storm drains.
Pam,
Yes.
We just had a question real quick about that ag plastic. So Laura was asking, are there compostable plastic substitutes for farming? And did you look at all at any differences between organic and conventional farming when you were studying the plastics?
I love that question. That's a terrific question. And actually that's another study that came out of this work on how much field plastic is used, that we found that that Washington State University has been working on biodegradable plastic mulch, that black plastic you see around strawberries, that that is a decomposable plastic that breaks down in the soil, so the soil microbes digest that plastic and turn it into CO2. So we've started working closely with Washington State University, and we've brought them here to Monterey, and we have a big grant with them right now to see if that kind of plastic will work for our local strawberry producers. So we've been using that plastic with 5 different farmers here locally, all of whom offered to do trials on their fields. And we've been having interviews with them and seeing how well it's working, and trying to see if, if it has the same performance characteristics for them that the regular plastic does, and then whether it breaks down quickly enough in the field for them to plant the next crop and have it not be a problem for field equipment or for the next crop that's harvested. So we're just doing it on a small scale right now, and we're just have our fingers crossed and hope that it's going to be successful. And then if it is successful, hope that it's going to be affordable. It does cost about twice as much as the other kind of plastic, but because they don't have to go through and pick it up at the end of the year and dispose of it, the total costs are pretty much equivalent, that they save on labor and save on disposal, so that overall it's a match. So we just have to see if it works, and then if it does work, farmers talk to each other, and if it does work, the farmers that are trying it are going to be talking with the other farmers. So thank you for that question. Yeah, that's a really important question, and something that we're really hoping it's going to work. So let's see. Oh, am I going the wrong direction? Sorry about that. So right now I'm doing a beach study on trying to figure out what kind of plastics are left on beaches in the Monterey Bay National Marine Sanctuary. So I looked at different activities that happen on the beach and different kinds of plastic that gets left on the beach from those activities. So for instance, smoking, cigarette butts get left on the beach, cigarette packaging gets left on the beach, vape items get left on the beach. Recreation, it would be things like balls, or frisbees or other recreational stuff that people do when they're on the beach. Personal hygiene, things like the face masks and gloves and other diapers, syringes. Those are all personal hygiene items that we find on beaches. Fishing line, fishing gear, buoys and stuff like that get left on the beach. Eating and drinking is a big thing. So about a third of our beach trash comes from eating on the beach. About 24% comes from smoking on the beach. And a lot of it comes from various activities where we couldn't really distinguish the item to know which activity it came. It was maybe a little piece of plastic. So that piece of plastic could have come from a straw, it could have come from a bag, it could have come from just too many different things. Or sometimes bags could be used for eating, and bags could be used just to carry clothing to the beach. So there, that got all put in various. So there was a lot of things, 43%, that we weren't sure what activity people were engaged in. But it was interesting that fishing, and this is both recreational and commercial fishing, did not contribute that much to beach trash, less than 1%. Recreation also was pretty low, less than 1%. So it mostly came, clothing wasn't much. Dumping distress is a little bit distressing. That's illegal dumping, like construction trash, or miscellaneous appliances that get left on the beach. Those were the major types of illegal dumping. But anyway, just that list on the left gives you an idea of all the different kind of trash that does get dumped and left on the beach, including cans and lighters and shotgun wads and fireworks and dog poop bags and syringes, balloons, foodware, 6-pack holders, tires. There's a lot of different things that get left on the beach. So over 5 years, and this was a 5-year period of time that I looked at, over 1 million pieces of trash. And this is not just trash left on the beach. This is trash that somebody bothered to count. So, obviously a lot of people are going around and picking up trash, but not entering that trash into an app that tracks it. So this is all came from apps that track trash, that gets counted by someone. I know probably a lot of you have gone out on the beach and picked up trash items and put them in a bin, a container, a trash container, and just didn't enter them into an app. Well, I don't know that. Then I don't know about that trash. All I know is about the trash that somebody entered into an app. So I venture to guess that a very small proportion of the trash gets entered into this app. So this is, maybe 1/10 of the trash gets counted. There's probably at least 10 times that amount of trash, because there's also people that get paid to go and pick up trash on the beach in Monterey. And some of the Del Monte Beach in Monterey, somebody rakes the beach and removes the trash that gets raked up. People in there's other people that are paid to go out and just pick up trashes, as well as a lot of volunteers who are just conscientious and go out and pick up trash. So this is a small percent of the total.
Pam, we have a question from Tani. Is there any data regarding microplastics in the ocean? Like what overall percentage comes from ocean adjacent communities versus the percentage that makes its way to the ocean from areas that are far from the ocean? And I also just wanted to give you a time check. We have 20 minutes remaining.
Okay. So yeah, no, that's a great question. And that's something that I'm hoping we might get some insight into with this beach trash study. We don't know how many of the microplastics that are in the ocean are coming from our beaches and our litter, comparing to how many are coming from the currents that are coming from Asia, or from the air that's going, deposited into the ocean. We don't know that. We just don't know. So I think that's a great question, and something that really, would be great to study further are the microplastics coming from the currents that come, from Asia and come to our coast, or are they coming from our beaches and rivers and going out into the ocean, and we're the main causers of that microplastic? That's a great question. And, we tried to get some research money to study that exact question, and our grant didn't get funded, but I hope somebody's grant to do that does get funded at some point. So this just gives you an idea of the worst offenders on the beach. The main trash that's found is plastic fragments, 26%, cigarette butts, 23%. People just not throwing their cigarette butts away, leaving them on the ground. This is in the parking lots by beaches as well as on the beach itself. But that's a lot, considering that only 10% of the population smokes. That's a really sad amount of contribution to beach trash. Wrappers is huge. Cigarette wrappers, food wrappers, I don't know, toy wrappers, anything that we wrap. A lot of wrappers are in beach trash. Bottle caps and bottles, more bottle caps than bottles, bags, foodware, straws, stirs, takeout food containers, and personal protective equipment. Of course, now with COVID, I'm sure there's a lot more of that than has been in the past, and other kinds of trash. But those are the top trash items. So I looked at different segments along Monterey Bay to find out where is the trash the worst. And I divided Monterey Bay into 30 segments, with the northmost segment up there by Marin County. The second one down is San Francisco. You probably recognize Santa Cruz's segments 11 and 12, 12 being more into Aptos and Capitola. And then segment 15 being Monterey. So you can see that some of the worst segments are where we have the bigger populations: Santa Cruz, San Francisco, Monterey, Capitola, Aptos. These are just some pictures of some fishing gear that got picked up out of the Monterey Bay National Marine Sanctuary, got collected and brought in. There's of course cargo ships, but we have a lot of wrecked vessels, and there's just one picture of a wrecked vessel. One of the people that I collaborate with a lot, Bridget Hoover in the sanctuary, she goes out on wrecked vessel adventures all the time. It just seems like she's out there every week with a wrecked vessel. So there's a lot of wrecked vessels that wash up on shore, but other times they get washed up onto the rocks and they just can't be recovered. So the plastic from those gets dispersed into the ocean. So I already showed this slide and I won't repeat it. So what can we do to make a difference? So obviously legislative answers on the federal, state, and local level can really make a difference. The plastic bag ban, I'm sure that's making a difference. Foam, not allowing takeout containers that are foam products, I'm sure that's making a difference. There's just a lot of legislative actions that can be really helpful to stop the plastic problem. On the corporate level, if businesses that make plastics, the manufacturers, were to accept the full circle life of that responsibility for that plastic, if we would demand that if they're going to make the plastic, they have to recycle it. If we would make that cradle to cradle demand, that would help. Right now, they aren't responsible to do that. And if we could redesign plastic so that it is more recyclable, or so that it's not plastic, it's something else, that would help. So if corporations would take increased responsibility, and some of them are, there are some corporations starting to accept that responsibility and make more of an effort to redesign their products or extend their responsibility for the whole product life cycle, not just from when it's used to when it's disposed. So taking responsibility for the disposed product. And then of course the individual, and we've all heard these 5 R's: refuse, reduce, repurpose, recycle, replace. You can try to have a zero waste starter kit. I try to carry stuff in my car so that I don't have to accept plastic cutlery. So I have the bamboo cutlery in my car. I have the little glass containers so that if I go and get takeout food, I can give them my container and say, could you please put my food in this container? And I'm certainly not an example of the most conscientious person, although I have to admit that studying this stuff does make you more conscientious about your plastic waste. So these are just some California policies that have helped with recycling and plastic use through time. Single-use plastic straw restrictions. You know, the restaurants don't automatically give you a straw anymore. You have to request one. Food packaging requirement that for state-owned property, they have to use reusable or recyclable or compostable foodware. Mandatory recycled content in plastic bags that's going to is going to be 50% by 2030. So, you know, hopefully that legislature will continue, you know, to have a positive effect. I noticed there's a ban on cigarettes that have these single-use butts. You know, the sad thing about cigarette butts is they don't have a health benefit. They do have an environmental consequence, but some people who have studied it have found that it's not reducing the cancer rate, that it's not benefiting the health of smokers, that it's just an environmental catastrophe with no health benefit. So why not ban them? Why not you know, don't put them on cigarettes anymore if they're not going to help. And maybe there can be a better kind of cigarette filter that has more than one use that somebody can buy that, you know, that has a health benefit, because those disposable fiber ones that they're using now, they don't benefit the smoker and they don't benefit the environment, but people have a perceived benefit. They think it's benefiting, but it's not. When you look at the studies and the research, it doesn't have a benefit, but maybe there's other kind of filters that could be used that would have a benefit, you know, that smokers would use if, you know, if the cigarettes didn't have those fiber butts on them.
Pam,
Yes.
Lenny is asking if there is any legislation in the works about plastic manufacturers taking responsibility for the whole life cycle of the product that you know of.
Yes. So, you know, I'm really, there's so much legislation out there that I haven't tracked it out, but there is a current California law that's requiring increasingly, not for all products, but for some products that manufacturers assume that full life cycle responsibility. And I need to learn more about it and find out more about it. But yes, there is the beginning of starting to make that a requirement, that as the recycled content comes up, you know, manufacturers like having to use 50% recycled content. So if they're going to produce a plastic container, they have to use recycled content in that plastic container. So there are laws requiring that full cycle responsibility. But it's not for everything. It's just for some of the plastics right now. So Santa Cruz is making some great laws, you know, no plastic straws, no plastic stir sticks, that cups must be compostable. So this is just an example that not only can the state do things, but cities can do things also that can help plastics. And individuals can, of course, do a lot to help plastics. And I just liked this little sign because it made me think of some things that I wasn't doing. So it brought some things to mind that I hadn't thought about, like, you know, maybe I don't have to buy everything. Maybe some of the plastic products I use can be shared. You know, maybe I don't need a plastic lawnmower. Maybe I can hire somebody who has one to use theirs. And I hadn't thought of that before. So buying higher quality items that are made to last. You know, we've gotten used to buying cheaper things, but maybe it can be less expensive for us if we buy something that lasts 15 years instead of something that lasts 3 years. So we buy that toaster oven that's made out of metal instead of plastic, and it's going to last longer, even though it costs more. In the long run, it costs less because we don't have to buy another one in 3 years. So I liked this little sign because I thought it was very thought-provoking. And that's the end for me. So are there any other questions? I hope that I hope this was interesting to you guys, and I'd be happy to entertain any additional questions.
Thank you, Pam. And thank you to the folks who have already asked questions. So if you want to stop sharing your screen, Pam, and if people want to put on their videos so that you can see them, we can we have about 7 minutes left from our scheduled time if people have additional questions. All of the questions in the chat have been answered at this point.
Well, thank you all for listening. I'm really glad you're interested in this topic. Thank you so much that you're interested enough and to spend your evening coming and listening to our findings and other people's findings, and you know why this is such a severe problem and some of the harmful effects. And thank you so much. It all starts with awareness and interest. You know, if we didn't have awareness and interest, the problem would get worse at a faster rate. So I'm just so happy that all of you have shown this level of interest to spend a whole hour and a half of your evening to look into this topic and think about it, and you know, and want to find out more about it. So thank you so much. I really appreciate your being here.
Well, we really appreciate your time, Pam, and thank you for the research that you've done and future research that you will continue to do to help us understand and take action to address these issues. There is another question in the chat from Inga Marie. She says, do you know of any legislation to include waste management and landfill costs into our taxes?
I don't know specifically about that. So I do know that waste management and landfills do give out a lot of grants, and I don't know where that grant money comes from, you know, whether it comes from the service fees or whether that's state money or you know, where it comes out. But they do give out grants to try to increase recycling. Like there was a facility in Salinas that was trying to recycle more ag plastic, and they got a big grant to build a facility to try to increase the recycling rate of ag plastic. And that's just one example. So waste management is very interested in lowering the amount of trash that they receive. So they're trying to increase the recycling of their trash, and they're trying to find ways to recycle and separate trash and people to send it to. You know, one of the things that I found is those bands that are used a lot around cargo, around, I don't know what to call it, you know, that's used as strapping tape. There was a lot of that along some of the streams that I sampled. And there's ways that that can be recycled, but it's just hard to collect it all. And it's hard to make it into teeny enough pieces that you can send it cost effectively. And waste management is trying to find ways to take all the different kinds of, including that strapping tape, and figure out how can we process it? How can we send it to a recycling facility? So they're definitely, we have a real leading edge waste management facility here that does one of the best jobs of any waste management facilities. And they're trying to find ways to increase recycling. And, you know, they can sell trash that they recycled, which can lower their, you know, lower the cost, I guess, to consumers. So, yeah. So yes, we are trying. I'm not sure I answered your question, but that's some of what I know.
Thank you for that. And then Inga Marie added a second note about whether eventually that could be part of the taxes that people pay, so there wouldn't be a separate charge for waste collection, and that maybe that would lead to less, more recycling and less dumping.
Yeah, no, that's a really good question, because when we think of illegal dumping, a lot of illegal dumping happens from people trying to avoid the fees associated with hauling something, to waste management. And, so trash or delivery of trash to waste management. I think that's a great idea. And, I don't know if there may be some other municipalities that may have tried that as a strategy. That's a great question. And I think I'll look around and see if anyone's tried it and whether it worked or not.
Thank you. So we mostly at this point in the chat, there's just appreciation, Pam, for you, for the information that you shared. People enjoyed the presentation, found it interesting and very important. So if we don't have any more questions or comments, I'll just remind folks, as Jonathan Pilch, our executive director, shared at the beginning of the presentation, we are collaborating with the Trash Talkers group and the County of Santa Cruz and other community organizations to hold waterways cleanups every month or two. So we've, the most recent one was in Casterly Creek. The previous one was in the Pajaro River bed, but please watch your emails from us. We will be letting folks know about those in our newsletters and other communications. And if you want to help us with our community forest efforts, we will be working at the Pajaro Middle School campus this Saturday, November 19th from 10 to 1. And our goal is to plant at least 20 shade trees as part of our school greening initiative that we're working on, which is also being supported by donations to our Monterey County Gives campaign. If you want to make a donation to support that work at Pajaro Middle School, we would really appreciate it. And then if you're just interested more generally in volunteer opportunities, you can contact my colleague Jose, Jose, Jose at watsonvillewetlandswatch.org, and he can put you on our volunteer opportunities email list and let you know about the next monthly new volunteer orientation. They're usually the fourth Friday of the month, but that is a holiday weekend this month, so it'll be rescheduled. Thank you all for how much you care about the environment and the work that Pam does, the work that organizations like ours do to restore and repair our watersheds, the wetlands and the bay. And again, thank you, Pam, and thanks to everyone who joined us tonight.
Thank you for pulling together the evening.
Sure. Okay. Good night, everyone.